Okay, guys, so today we're going to learn about calorimetry. And literally, this is how scientists measure delta H values, enthalpy values in the lab. And so there's two major methods to do this. You can use a coffee cup calorimeter, which is made of a styrofoam coffee cup. And what the whole goal is to add some sort of solid, and then as it reacts we want to see how much energy is absorbed or given off, and we have a thermometer here to measure the change in temperature so we can calculate that. And if you guys will remember, what equation do we use when we're trying to figure out the heat that's being given off or absorbed? We're going to use QMCAT, so Q equals MC delta T. Okay, just as a reminder, and I'll go through the different variables in a second. Um, the other type of calorimeter we can have is a bomb calorimeter, which is something probably you've never heard of before, but it's comprised of metal cups. So this outside is a metal cup, and then there's a metallic chamber in here. And this bomb calorimeters are used when you have to do a combustion reaction. So you would never use a coffee cup calorimeter for that because I don't think it could hold up to an explosion, right? So the way this works is they add oxygen to the reaction. That's what's there, and whatever the substance is reacts with the oxygen, and the combustion takes place, and then it gives off energy into the surrounding water, and then that's recorded with the temp by the thermometer there. Okay, so that's how that works. So let's look at the heat equation real quick. So in the heat equation, remember Q is the heat, and that's, or you can just say the energy or heat in joules. I'll put heat energy. M is the mass, and remember that needs to be in grams. C is a specific heat, and that's joules per grams degrees C. And delta T is the change in temperature. Sorry, this is messy. I'm just trying to write fast. And so that's what we plug in for those. When we use C here, that's always going to be C for the specific heat for the liquid water. And I'm going to put it down here because there's a spot for it. So liquid water is 4.184 joules per grams degrees C. Remember, when you're doing Q calculations in general, pay attention to what phase the substance is, because if it's not liquid water, it's not going to be this. It's going to be a little different. Okay. The definition of the specific heat value is the amount of energy. So I'll put here energy in joules needed to raise 1 gram of substance 1 degree Celsius. That's the definition of specific heat. Okay, so if we go over to the bomb calorimeter, again, this is for the combustion reaction type situation. This is a little different formula for this one. Okay, so I'm going to write that in just a second.